Hi everyone. We are going to learn about hypothesis testing with a proportion. So, I want you to do fill in the blank notes. And I should have posted blank notes that look just like these that I'm going to be doing. And I want you to fill these in with me as we go, just as you would if we were in class. So, get your calculator, get a pencil, and let's roll. Here we go. U.S. Department of Commerce reports that in 2022, 31% of cell phone users had Verizon as their mobile provider. I do too. A random sample of 1,100 cell phone users this year shows 600 prefer Verizon. If appropriate, test whether the population proportion who prefer Verizon has increased using a 5% level of significance. We're going to write down everything we know. Okay, test the original claim. The proportion has increased, so that means that the proportion is greater than 31%. The proportion is greater than 31%. Or you could write it as the proportion is greater than 0.31. Is that your null or is that your alternative? It doesn't have an equal sign, so that means it's your alternative, and the exact opposite of that would be your null. Less than or equal to 0.31. This is a proportion, so we are doing a one prop z-test at the 5% level, so alpha is 0.05. Okay, and just like when we were doing confidence intervals, we need to go through and find x and n. And they may tell us x, they may not tell us x, and they'll tell us n. So n is 1,100. Cool. And it says x is 600. Great. But they may have said, this year it shows that 60% prefer Verizon, and you would have to say 60% of 1,100, and that way you would get x. Okay, now we're going to do the test. Get your calculator, and here we go. Here we go. Okay. Stat, test, and you see there's all kinds of tests over here. One proportion z-test. P0, that's the proportion we're testing against. We're testing against 31%. And they may have said, well, next year we think it's going to be 50%. Well, whoop-de-doo. We're testing against what the claim is. The claim is 31%. Claim is 31%. X is 600. N is 1,100. And this is all on the sheet that says, do not lose this sheet. And I'm going to show you. You write your claim, you write your null, you write alpha, we write our test. Okay. So anyway, that is what we are doing. Okay. This is extremely important using this. You'll notice that none of these have equal signs. And it has your proportion. That means the proportion that we chose up here is P0, which is 31%. Our proportion doesn't equal 31%. Our proportion is less than 31%. Our proportion is greater than 31%. But what you need to remember is make it match your alternative. Our alternative is greater than. This needs to be greater than. It matches your alternative. That is extremely important. It doesn't have an equal sign. This doesn't have an equal sign. Make them match. Calculate. Here we go. Calculate. Calculate. P is 3.08 times 10 to the negative 64. Wow, that's like almost 0. So we're going to make our p-value 0 plus. 0 plus. So p is very, very small. Okay, on the sheet that says do not lose this sheet, it says if p is low, the null must go. Okay, there's actually a real saying that says if p is less than alpha, you reject the null. If p is greater than alpha, you fail to reject the null. You don't ever say except, you don't ever say that, but you can remember if p is low, the null must go. So for us, p is less than alpha. So p is low. Null must go. So what you're going to do is come up here to the top and you're going to mark out your null very, very lightly, and you're going to circle your alternative. That means that's the one that you actually believe. You believe your alternative is true. So we believe the alternative is true, and we're going to check to see, does it match what we claimed? Does this match what we claimed? Does it match? Yes, yes, it matches. It matches what we claimed. And that makes you very, very happy. It matches what we claimed. Okay, so conclusion in simple terms, and this is also on your sheet that says do not lose this sheet. We would say there is enough evidence to support claim that more people prefer Verizon. Okay. There is enough evidence to support the claim that whatever you claim is true. Sorry that you can't read my writing. My pen is crazy in this app. But that is sort of what's going on. You write your null, you write your alternative, you figure out what test you're using, you figure out alpha, you do the test, you find your p-value, and then you make the claim. Okay, we're going to do one more of these. Okay, in 2019, 58% of females age 18 and over reported living alone according to the National Census Bureau. Okay. A sociologist tests whether this percentage is different today by conducting a survey with a random sample of 500 women, and he found that 315 are living alone. All right. Is there evidence at the 5% level to conclude that the proportion has changed? Changed. What does changed mean? Changed means that it's not equal anymore. The proportion is no longer 58%. Oops. Okay. The proportion is no longer 58%. Okay, that means that that will be our alternative, and the null would be that it is 58%. Okay, we're still doing a one prop z-test at the 5% level, and let's write down x and let's write down n. So x is, or n is 500, x is 315, and that's all we need to know. Okay, let's do it. Stat, test, one prop z-test. Okay, the proportion is the proportion you're testing against, 58%. X, we have 315 women out of a total of 500. And remember, this is the direction of your alternative. It has to look just like your alternative. Our alternative is not equal. Not equal. Calculate. Calculate. And you'll notice that we get a p and a p hat. P hat is just x divided by n. We don't care. We don't care. That's just a fraction. We want p. P is the percent of time that we could be making this error. So P for us is 0.023. 0.023. So P is less than alpha again. Oh, okay. P is low, null must go. P is low, null must go. If we'd got something like P is 0.026, we would say P is high, the null must fly. And we would circle the null and we would keep the null. But this time P is low, the null must go. And we mark out the null and we circle the alternative. And do they match? Yes, they do. And again, there is enough evidence to support claim that the proportion of women living alone has changed. ... Okay. So you're going to be trying these others on your own. Give it a go. Your claim will not always be your null. We know that. If your p-value is higher, you may be circling your null, you may be circling your alternative. It's going to vary, but I want you to try the other two on your own, and we'll just see how those go. Okay, give it a shot. Hope it goes well, and we'll see. I can't make my recording stop.